Now that we understand what threads are and what they're used for, let's look at threads in a bit more detail. In this video, we'll talk about how to create threads as well as understand what the different states of a thread can be. Each thread that we create will be associated with an instance of thread class. Now, thread class is a class that is already defined in Java. But before we go into the details of what thread class looks like and what the methods in thread class are, let's look at one example. Let's say you have a process which is used for file sharing. Let's say that is an application. And let's assume that the main thread allows us to do a few things. For example, browse files, read files, upload files, and download files. Let's say you're trying to find a file, but at the same time, you're also trying to download a file in the background. If there is only one thread doing everything, then you would not be able to do anything simultaneously. So let's look at the example of downloading. Let's say you're browsing the files, but at the same time you want to download some file in the background. How would we do that? What we can do is that we can create a new thread that will handle the download task. And while that is happening, you can keep on browsing and reading other files. So the main thread can create a new thread and then assign it the task of downloading a file. So there are two things that we need to keep in mind here. At first, we need to create a thread, that is number one. And number two is we need to give that thread some task that thread would carry out. In this case, our task is to download the files, and thread 1 will carry out this task. Now, while thread 1 is carrying out the task of downloading files, the main thread can allow us to keep on browsing files and reading files. And so you see, this is an example of a concurrent process. We have two different threads, the main thread and thread 1, and they're both doing different things at the same time and allowing us to use the main thread to keep on working whatever we're working on, while in the background, thread 1 downloads files. Now, when we create a thread, we basically create an instance of the thread class. The thread class has a lot of methods that are already predefined in Java. Let's look at a few commonly used thread class methods. The thread class in Java has a few attributes and methods that are important to know. There are many ways you can construct a thread, so the thread class has many different constructors. What we want to look at are these three fields. These are predefined in the thread class. The fields are integers, and their names are maximum priority, min priority, and norm priority. The max priority attribute is a static integer, and this is the maximum priority that a thread can have. The same is true for this attribute, except that it is the minimum priority that a thread can have. Norm priority is a static integer, and when every thread is created, it is given a default priority, and that is the norm priority. Remember that the maximum priority of a thread can be 10. The minimum priority of a thread can be 1. And usually each thread, when it's created, has a default priority of 5, and that is the value of the norm priority attribute. What is priority used for? We'll understand that when we look at thread schedulers just a little bit later. Let's look at some of the methods that are very important. The first method that we want to highlight is the start method. When you create a thread, and we'll look at how to create a thread just in a few moments, but when a thread is created, we need to give the command to start executing it. And we use the method start to do that. When we use the start method, at that point, JVM calls the run method of this thread. And we'll also look at what the run method is in a few moments. The next method we want to highlight is the sleep method. When we use the sleep method for a thread, it causes the thread to pause temporarily. It causes the thread to temporarily cease execution. And we can specify exactly how long we want a thread to sleep. One other important method is the join method. So if we use the join method for a thread, what JVM does is allows that thread to complete execution and die before it executes any other threads. So if we have a thread T, let's say, and if we call t.join, what would happen is that the process would wait for T to complete execution and terminate. And only after that, it would allow the other threads to execute. So join is an important method to know. We can give our threads names, and the set name method allows us to name our thread. If a thread already has a name, then we can also use the get name method to get the name of that thread. We use the get ID main method to get an identifier for a thread, and usually identifiers are numerical values. There are many other methods, as you can see in the thread class, but the last thing we're going to talk about is the priority. And we can use the get priority method to get the priorities of a thread, or we can manually set the priority of a thread. Usually we pass an integer as the new priority, and this is an integer between 1 and 10, 10 being the highest priority. Great. Now that we know what the different methods of the thread class are, the question is, how do we create a thread? There are two ways in which we can go about creating a thread. We can create a class that extends the thread class, or we can create a class that implements the runnable interface. So runnable is an interface in Java that is already defined, and any class whose instances are intended to be executed by a thread should implement the runnable interface. Our thread class in Java already implements the runnable interface. But if we are not extending a thread class, we should implement the runnable interface ourselves. Runnable is an interface in Java, and any class whose instances are intended to be executed by a thread should implement the runnable interface. The runnable interface only has one method, and that is the run method. So when an object is used to create a thread using the runnable interface, and if we start that thread's execution, at that point the run method of that thread would be called. And we will look at run method in a bit more detail in a few moments. So let's look at how we can use extending the thread class to create a thread. Let's say we have a class named download, and this class will carry out the task of downloading files using a separate thread. Because we want this task to be carried out by a thread, we make the download class extend thread class. So let's say the download class has an attribute file, and file can be any type of object. The most important method that we need to define is the run method. Whatever task we want to carry out using a thread will be defined inside the run method. Here our task is to download files, so the code that defines that task will have to be written in the run method. So the run method is extremely important because it defines what task a thread will carry out. So let's say we define our code here. We write our code to download files within the run method. Great. Now we have a class that extends thread, and we have also defined the run method for our class. Let's also define a constructor for our download class. And we can have a simple constructor that takes in a parameter. This parameter can be the file that we want to download, and then we can write our constructor code here. And now we have our download class. So to recap, the download class is a class that we want to use when we want to download a file using a separate thread, which is why we have extended the thread class. Whenever we are creating a thread or any class that is intended to be used using threads, we always have to define a run method. And in the run method, we will have the task that we want a separate thread to carry out. Great. Now we have our download class. So in the main class, we will have our main thread code. And the main thread code would allow us to browse files and read files and maybe some other things. But whenever a user wants to download a file, maybe they click on a button, maybe a download button. If a user clicks on a download button corresponding to a file, in that case, what we do is we want to create a new thread and ask that thread to download the file in the background. So here, what we'll do is we'll create an instance of our download class, and we will use the constructor that we have defined here. Now, because this object D1 is an instance of the download class, and download class is a child of the thread class, we can think of the download class instance as a thread in itself. So we already saw that the thread class has a method called start. Now, since download object D1 is a child of thread, D1 will also have a start method. So now if we type in D1.start, our thread is now ready to execute. And this would conclude our main method. So this is a very simple example of how we can create a thread using a class that extends the thread class. We created a download class that extends thread, we created the run method, and then we used an instance of the download class in our main method, and then we used the start method. for D1. What this statement does is that it creates a new thread because download itself is a child of thread. So we have a new thread using this statement. Once we have that new thread, we then ask the thread to start executing. So I hope you understand how we can create a thread by using a class that extends thread class. Let's look at how we can create a thread by using a class that implements runnable interface. So if we were implementing the runnable interface instead of extending thread class, we would have defined our download class like this. We would have said class download implements runnable, and runnable is our interface that is already defined in Java. We will have the same file object as a private attribute of our download class. And here also we'll have to define a run method. In the run method, we will write the code that would allow us to download files. We can also have a constructor of the class, and now we have our download class that implements runnable interface. So what's the difference between these two things? Both of them have the run method, and both of them have the code to download files inside the run method. The difference is in how we use them. So if we go to the main class, in the main method, we will have our main thread code. Now, again, if a user clicks on a download button corresponding to any file, at that point, we would want to create a new thread and then give that thread the task of downloading files and execute that thread. So we create an instance of our download class. But here is the key difference. When we created the instance of the download class here, the download class itself was a child of the thread class. So we could treat D1 as a thread itself. Here, the download class is not a thread because it does not extend the thread class. So we cannot start D1. What that means is that we have not created a thread yet. Here, when we created the download object D1, that meant that we already created a thread because download class was extending the thread class. And so download is a child of the thread class in that case. Here, we have not created a thread yet because download is not a child of the thread class. So what do we do? In that case, we need to create a new thread using the thread class itself. So T1 is an instance of the thread class. And now we have created a new thread. In this new thread, we pass the D1 download object. And so now our new thread knows what task it needs to carry out. It knows that whatever was passed to it, in this case it is D1, that must have a run method. And D1 has a run method because D1 is an instance of our download class that implements runnable. And so now, since we have a new thread and that thread now knows what task it needs to run, we can start this new thread. And so we type in t1.start, and that concludes our main method. So both of these ways allows us to create a new thread and assign it a task to carry out. So what's the advantage of one way over the other? So typically we extend thread when we want to override any of the thread methods themselves. And we want to create a specialized way of using any of the methods that thread already has. So if we want to override any of the methods of the thread class, in that case, we usually use the way of extending thread class. But if we are just creating a thread and we do not intend to override any of the methods in the thread class, in that case, it is always better to use the way of implementing runnable interface. Also remember that a class in Java can only inherit from one class. So if you want a class that can be used to carry out tasks using a thread, but also wants to inherit from other classes, in that case, this method of implementing runnable interface is a lot more flexible because now you can extend from another class as well. But if you have already extended thread, the download class cannot extend any other class. So it really depends on the usage that you would need, particularly in the application that you're building. Now that we understand how to create threads and how to give threads a task to carry out, let's understand the concept of thread scheduler. What does a thread scheduler do? A thread scheduler decides which thread to run. What does that mean? Think of a process, maybe an application. Each process must have at least one thread, right? So that thread is usually the main thread. However, that process can have many other threads that are doing things simultaneously. And all these threads have different tasks that they want to run. All of these threads are created by the main thread to carry out different tasks. Now, the thread scheduler decides which thread runs at what time. There are two main ways in which a thread scheduler decides. which thread to run. There is preemptive scheduling and there is time slicing. Each thread that we create has a default priority, and we already saw when we looked at the thread class methods that we can set priorities of different threads. So with preemptive scheduling, the threads with higher priority are executed until even higher priority tasks appear. So this type of scheduling is dependent on the priorities assigned to each thread. For time slicing, a task executes for a predefined duration of time. After that, it goes to the runnable state, and a different thread comes in and is executed for a small amount of time, at the end of which that thread goes back to a runnable state and a different thread is executed for a predefined duration of time, and so on. So once a thread is executed for a predefined duration of time, after that the scheduler decides which task it will run next, and that depends on many different things, including priority and other factors. The question now is, why do we need a thread scheduler? This is because for any process, only one thread runs at a time, and it is very important to remember. Only one thread runs at any one given time. Why is that? That is because all these threads are sharing the resources that are given to the process. The requirements of each thread in terms of resources are different, as well as the priority of the tasks that each thread would carry out, which is why, in order to utilize the resources efficiently, only one thread runs at a time for any given process. The thread scheduler decides which thread that is going to be. The next thing we'll look at is the different states that a thread can be in. There are a few different states that a thread goes through throughout its lifetime. The very first state is the new state, and for us, this was the new state when we were using the method of implementing runnable interface. Here, T1 is a thread, and it has just been created. This is the new state for thread T1. In this case, when we created the object D1, download is a child of thread. Here, D1 is our thread, and the state of D1 is new because it has just been created. So a thread state remains as new until we use the start method. So we say a thread is in the new state when it has been created, but it has not been started yet. The next state that a thread can be in is the runnable state. And do not confuse the runnable state with runnable interface. This is just the state that a thread can be in. Here, runnable is an interface that a class can implement. So what is the runnable state? The runnable state is interesting. When we start the thread goes into runnable state. But that does not mean that the thread is executing. It only means that it is ready to execute. It is the job of the thread scheduler to take that thread and execute it. So the runnable state is a state when the thread is ready to run, but the thread scheduler has not selected it yet to be executed. And when the thread scheduler selects that thread and is executing it, at that point we can say that the thread is running. But until that happens, the thread is in runnable state because it has been started using the start method, but the thread scheduler has not yet selected it to be executed. Maybe the thread scheduler is currently executing some other thread, which is why our thread is still in a runnable state. The third state that a thread can be in is the blocked state or the waiting state. We can also call it the non-runnable state. At this point, the thread has been started using the start method, but the thread is not runnable because it might be waiting for some other thread's results, and maybe this thread now needs that result in order to carry out its own task. Or maybe the thread has already carried out a part of its task, but the next part of its task might need results from somewhere else, and so it might be in the blocked or waiting state, waiting for that result to come through before it can go back to the runnable state. And the last state that a thread can be in is terminated. Either the thread was forcefully terminated or the thread has finished its task and there is no more use for the thread anymore. Based on when a thread scheduler selects or does not select a thread to run, a thread keeps on switching between states of being runnable or blocked or waiting, while other threads are executed. Each thread waits for its turn to execute a small part of its task based on how much time the thread scheduler allows that thread to execute. Great, so now we understand threads in a lot more detail. We know how to create threads by using two different methods. One is extending the thread class, the second is implementing runnable interface. we know that we need to implement a run method, and in the run method, we write code for the task that we want the thread to execute. We also know what a thread scheduler is and what a thread scheduler does. We have looked at different methods in which thread scheduler schedules the execution of threads. And we have also briefly discussed the different states that threads can be in. In the next few videos, we'll look at some of the methods of the thread class in a bit more detail.